Hello again, everyone. Today I will look at a key hypothesis for human language that dominates the world of formal and computational linguistics. And next time we'll look at how parts of speech, also known as lexical categories, have blocked our progress so far. That's next time. By excluding meaning, the analysis of languages seems ill-equipped to solve NLU, as language understanding depends on the meaning of words, don't you think? For 40 years, scientists and engineers toiled to make parsers work as the first step in understanding a sentence, with rules-based systems, and then statistics were applied to continue that struggle for the elusive parser in a 20-year additional effort. And now statistics are being replaced by artificial neural networks, but that seems unlikely to change anything, as doing either a faster job or a less labor-intensive job isn't the real goal. There's a fundamental change needed to move from parsing sentences to understanding discourse. Context and meaning must be added. Meaning needs to be a part of NLU, and neither a statistical application can address the impossible rules-based problem, nor can replacement of statistics with deep learning systems inject meaning. Meaning is missing. When you compare formal linguistics to functional linguistics with systems like role and reference grammar developed by Robert Van Valen promise the exploitation of a new breed of systems based on meaning. Okay, let's have a look at syntax alone for NLU versus a meaning-based approach. And what we'll use is the meaning matcher to illustrate the differences between a parse tree and a meaning-based system. This is a key to today's discussion. Everything should be as simple as possible, but not simpler. And I think what Einstein meant by that is that if you have a simple scientific model, that's great, it should be simple. But if it's too simple, you don't get the right scientific output. And here's possibly the best illustration of that point. So the role and reference grammar, which is the functional model that we've embraced, is composed of three elements of three sides of this triangle. You've got the syntactic representation, a semantic representation, so the meaning representation, and then discourse pragmatics, which is like the context, so the information that you're tracking in that conversation in order to know who said what to whom and be able to deal with that. Note also that there's a linking algorithm that connects the syntax to the meaning, which becomes evident as we look at the actual examples. So today we're going to look at the language science of formal linguistics, the Chomskyan model of the world, in which a word is a sequence of letters. So there's no underlying meaning, there's just that sequence of letters, and you need to use rules in order to create syntactic structure. And later, not today, we'll have a look at functional linguistics and how that solves the open problems. So to start with, parsing is an old model. So going back to the 1930s, Bloomfield, who was a behaviorist, looked at how to model language. He actually went back to the Indians, as in from India, in the maybe 500 BC, where there were people that had modeled how Sanskrit worked. And so these parts of speech then became the cornerstone of this constituent analysis. The interesting part to me is how long this one model has persisted, despite it not applying effectively to NLU. So on the left-hand tree there we have a modern example of this constituency analysis, and on the right-hand side we have the formal language theory and a couple of derivation trees showing the ambiguity that can arise. To me, we have a problem with the science. When you're inside a scientific hypothesis that's not helping you, you're kind of stuck with how you get yourself out of it. It's not something inside the system that solves it, it's something outside the system. In our case, NLU is stuck inside the system of syntax first, when in fact meaning and context needs to be integrated into that. And there's a good parallel here with epicycle. So the old geocentric Earth model, where the Earth's the center of the universe and there's these circular orbits of planets going around it, it's a good analogy because once you're doing your scientific studies and you're following the planetary motion, you realize that planets aren't following this nice circular path. There's a concept of retrograde motion. And what people at the time did, and 1,000 years is a long time to be stuck in one particular paradigm, but during those times people invented more and more innovative ways to explain something that actually makes no sense. And it's pretty hard to make sense of it because the Earth actually isn't stationary with the sun going around it. It's the sun at the center with the Earth going around it and the other planets. But you can see in these two diagrams that epicycles started to explain this retrograde motion, but didn't quite work. And then people added epicycles to epicycles, so circles on circles on circles, in order to try and explain what was being seen. And ultimately it came to Isaac Newton, who came up with a force equals mass times acceleration model that explained the actual elliptical orbit of our solar system with the sun as one of the focal points. So those were observations that had already been made and validated, but that one equation from Newton finally had a nice equation that explained all of that motion. So here's a hypothesis. The fundamental aim in the linguistic analysis of a language L is to separate the grammatical sequences, which are the sentences of L, from the ungrammatical sequences, which are not sentences of L, and to study the structure of grammatical sequences. Noam Chomsky, 1957. This is very influential, and there's an obvious question that gets raised. Why is this the fundamental aim in the linguistic analysis? Okay, it's definitely the fundamental aim in producing that constituency tree. So to create a tree, as Bloomfield's model does 20 years before this, it's great to create that tree in order to see the constituency relationships. But the fundamental aim of linguistics should surely be to dealing with the communications of language, of human language. Now, formal linguistics also applies to computer models and to various other technologies. So, granted, computer models work off formal linguistics, but human languages don't, and I think the reason is because we're excluding meaning and context. But let's just follow through the reasoning. So Chomsky argued that the sentence "colorless green ideas sleep furiously" is picked up by an English speaker as grammatical. What does that mean? Well, it means that those word sequences, for some reason, follows valid word sequences for English. Okay, well, that's acceptable. But why is that the thing that we're studying? Because it's the words that somehow have this extra meaning that seems to matter, which in the case of rules would be parts of speech, but there's other ways of modeling that. What if we said "less color green ideas sleep furiously"? That's not grammatical. The only thing I've changed is I've added this new word, "less color," that you don't know what it means. And therefore it then ruins the whole sentence. So grammaticality is about the word sequences that are allowed, but somehow there's something underneath those words that's actually driving the validity for English and the other world's languages. So let's keep going. Here's my analysis of colorless green ideas sleep furiously using modern terminology, certainly that was used in the 1990s for corpus linguistics, and then the one below, which is possibly more familiar to most people. So colorless green ideas sleep furiously is adjective, adjective, plural noun, verb that's not third person singular and present, followed by an adverb. So if that's the grammatical representation of that meaningless sentence, surely if we derive from that using those same definitions, we should get another grammatical sentence. And there we go. Running, running, runnings run furiously. That doesn't seem like a grammatical sentence to me. So the adjective, adjective, plural noun doesn't just generate meaningless sentences, it generates ungrammatical sentences, at least whatever grammatical means. But you can see below it, "small round birds eat hungrily" is also following exactly that same grammatical pattern, and it works fine. So there's something about the syntax that's useful for language, but it can't be the only thing because it generates ungrammatical sentences. And you can then take this a lot further. We start with that grammatical example to the ungrammatical example, but as you run down this list, you can get other examples which are based on meaning, where you can go from meaningful to meaningless by substituting into those sentences. Just want to draw your attention to the last two. So if you're on a train station and somebody walks up to you and goes, "Me go city," Por favor. What does that mean? Well, to me it means that that person wants to go to the city and maybe you can help him. So we could substitute in with I will go to the city to make that a grammatical sentence. But that's basically showing an ungrammatical utterance from a non-speaker to a grammatical example, which also means something. They're both meaningful sentences in English. Let's look at the next one. The woman fell down that was attractive. Ungrammatical. The woman that was attractive fell down. Grammatical. So we can go from ungrammatical to grammatical, but they both are meaningful. To me, both of those sentences are completely understandable. So what's going on here? Well, there must be a way of substituting into these sentences so that they stay meaningful and the grammatical nature of it isn't that relevant. Okay, this is a paper from Dandrafsky, 96. You can see that what he's showing is that one of the linguistic models is saying that the woman fell down that was attractive is grammatical according to a theory. But he's spoken to informants and they agree it's not at all grammatical. So he's saying it's an ungrammatical sentence. Now the concept of parsing is that you take these word sequences and you work out if it's allowed for that language, and that's the output of your parser. So Jurafsky is saying, again, a world-renowned computational linguist at Stanford is now is arguing that the woman fell down that was attractive is ungrammatical, and therefore it shouldn't be the output of a parser. So how is NLU going to work if somebody were to say that sentence which you and I can understand, but the parser says invalid? There's your problem with syntactic-only systems. And look, we're going to break this down a lot more, but I just want to talk you through some of the sentences that I'm going to show you in a separate video, but also in a moment I'm going to give you the breakdown of one of these sentences. So, the man ate the tuna continuously here today, evidently. Okay, so that's a nice English sentence. But interestingly, continuously here today and evidently are all adverbs. So the adverbs are obviously allowed to run in a sequence according to the grammar only. But meaningfully, it's different because continuously here today evidently isn't just adverb, 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 adverb. It's actually how, where, when, how. And there's actually subcategories of how which are taking place here. And I know that's not a common, it's not a syntactic term, it's a semantic term, and we'll get into more detail on a later date. But fundamentally, there's a specific order that works best for English. Now, if we convert that sentence into a question, has the tuna been eaten by the man here continuously today, evidently? Again, it's a pretty complicated sentence to follow, but you finish up being able to break that sentence down into its parts of speech. Verb, determiner, noun, verb, verb, preposition, determiner, noun, adverb, 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 adverb. So if you swap the verbs around in the next sentence, you can see it becomes gobbledygook. If you just swap around the order of those four adverbs, you can see it's not meaningful either. Has the tuna eaten by the man evidently continuously today here? You go, whoa, whoa, what's that? In a moment, we'll have a look at this next sentence, these next three sentences. John pleases Beth. We'll look at the meaning of that. We'll then look at John is eager to please, which is using a juncture in order to have two different sentences, or two different cores combined there. And John is easy to please, also combining in a juncture. And then finally, we'll look at the shark bit. No ate the surfer the dog saw at the beach today because it was hungry. Because there we're seeing error correction, and then we're seeing the different elements of meaning that go into a sentence that NLU needs in order to take advantage of it. Okay, so let's look at the examples now. You can see them there. I go to the city, I will go to the city, I want to go to the city. We're going to look first at those examples, and then we're going to go through the meaning of the word please and then the types of junctures that we can use. So let's get into it. So first, I go to the city. What does that mean? And in this case, we're just using the online API. So you can see that we've broken down that. We're actually translating I into you because we're talking to the machine. So it recognizes it as you in conversation. But then we've got the meaning of go, which is to change location, and then to the city is our goal, our destination. So the point to make here is that here it's an activity. I go somewhere, whatever going is, and then that was the activity, and then the end result is that I'm in the city. Okay, so that's what I go to the city means. Now, if we look at the next one, I will go to the city. You'll notice the difference. Oh, you probably won't notice the difference because I didn't highlight it. But see here, we've got future. So that's now future tense with a high obligation. We'll cover those types of things in a bit more detail at another time. But that's a future I will go to the city as opposed to I go to the city, which is just a positive present statement. And then I want to go to the city. This introduces a juncture. And what we're getting at is that person on the train station saying, me, go, city. How is it we can understand what that means? Well, because we have this system where here's me. We've got a definition for that. It's a pronoun. Go is the movement, and then to the city. Or in this case, I want to go to the city. So we've got I want with a juncture. What do I want to do? Well, it's the thing that follows from the juncture, and then in this case, I go to the city. So what we've done by using this technique is the other part of the juncture is exactly the communication which me go city roughly means. Okay, so let's move from how it's possible to understand things that are very basic. I go to the city with John pleases Beth. So let's have a look at the meaning of that one. So here in the logical structure, John does something, so that's causative. John does something which causes Beth to become pleased. So in here, that's the end logical structure, semantic representation that we've received. We've got an actor, we've got an undergoer, and the predicate. So John pleases Beth. John is the one doing the pleasing. That's the which becomes the causer in the logical structure, and then Beth is the one that's pleased. So we've got here become pleased Beth. Okay, so that's what pleased means. Now let's just use these junctures and see how they're handled. And these were some of Chomsky's early examples of the challenges for syntactic structure. So here we've got, it's easier if we look at the juncture in the two separate logical structures. So John is eager means this. John is the actor of eager, and the thing that he's eager for is that X. And the thing that slots into the X is actually John pleases someone. So we've got John as the actor pleasing someone, and then the second part of the juncture is that eager one. So John causes someone to become pleased. And notice how that differs from John is easy to please. Just go back, let's put that one in. John is easy to please. Here easy means X has got this attribute of easy. But what's X in this case? Somebody does something which causes John to become pleased. So if John is easy to please, notice that John's the one that becomes pleased. If John is eager to please, it's John that's doing the pleasing to someone. So it's very nicely explained with the concept of the juncture. Let's just have a couple look at a couple more junctures. This is an actor juncture. So the actor is the thing that gets passed across the juncture to the second core. So here we've got John promised to please Beth. So John is the one that pleases Beth in this case. So because it's this promise, because promise takes its actor and it passes it through the juncture to the next core, we've got there John pleases Beth. So John causes Beth to become pleased, and then you can take that whole thing and you put it into that X there. So that's John promised to please Beth. Let's compare it to John persuaded Beth to please. So what does that mean? Well, it's probably easier if when we get to the next one, but let's just see what it means. John persuaded Beth to please. So here John persuades Beth. So John says something to Beth which causes Beth to want something. In this case, what does Beth want? Beth wants to please someone. So Beth does something which causes someone to become pleased, and John does the persuading. So in the case of persuade, it takes the semantic undergoer and passes that through the juncture. So see how Beth has been passed down here. Beth then becomes the actor of this second core. And then we've got a full semantic representation up there if you wanted to see the end result. But let's just look at one more extension to this, and that finishes us for now. John persuaded Beth to please Sue. And in this case, Beth is still the undergoer of the persuade, so Beth gets passed through to the second sentence, and we can see here that Beth pleases Sue, John persuades Beth. So the undergoer Beth is passed across the juncture, and so Beth is the one that wants to do this thing. In this case, Beth pleases Sue. So there you have it. There's a quick introduction to meaning. It's, in my view, a much more elegant and logical way of recognizing these particular types of sentences. So we've looked at syntax-only systems. Let's look at a meaning-based system. So here we have a network of elements, and this is the hypernym association, so the is-a type relationship. So Dana is a person is an animal is an object. And using just that one network, we can then, by making it a semantic network, we can then do some interesting things by simply connecting a few pieces. So if you had the meaning of eat, and you knew that animals, as the actor, eat undergoers, which are food, you can now start to make sentences that are completely accurate simply by substitution. And the substitution process is anything above the hypernym relationship that we have, or hyponym, depending on which direction we're going. So you've got animals eat food. There we go. That's a valid English sentence. How about going up one level? People eat cereal. Sounds okay. We've got tuna and salmon, which are fish, and the fish, they can also be food. So you can have the tuna, fish, eats salmon. You could have the tuna eats tuna. You can have the salmon eats salmon, or the salmon eats cereal. All of those are substitutable. That's meaning-based substitution. So I'm not saying this is the only solution to how we can put together sentences, because obviously I'm only working off the meaning there, not off the actual English phrases. But that's the concept. There's other solutions to just syntax. Okay, so look, it sounds like I'm a bit of a naysayer, but let's just keep going with parsing. Well, we've worked on it for 62 years since Chomsky, since cognitive science was formed, and it doesn't really work. We don't have any parsers for any language that has ever been accurate. Not human level accuracy, not even close. So we'll see a parser from Google shortly, which is in the 90s for certain types of parsing problems. But that's not human language. 90% is still one word wrong in 10, and if you've got one word wrong in 10, it's hardly intelligible. And here's one of the reasons why. So I'm going to be picking on Dan Jarafsky today, because he's obviously an extremely credible source. 1996, here's in that same paper him pointing out that parsing with the full amount of ambiguity in language is NP complete, so it's unsolvable because of the amount of computation required. And another paper had said that it's proportional to the Catlin numbers, and you can see I've got below there the Catlin numbers 1, 2, 5, 1442, 132, 429. It's getting up to a huge number very quickly. In our meaning matcher, we use set-based matching, not this tree-based matching, and as a result, that isn't even a theoretical concern. But wanted to show you that parsing cannot work because the people who are the experts are saying it can't be done. Well, what happened when the rules-based systems through to the 1990s failed? Well, people didn't just give up. They started to do these types of things. So here's Jarafsky's statistical system looking at discussing dogs on the beach. And the question is, if you're discussing the dogs on the beach, are the dogs on the beach or is your discussion on the beach? And this is showing that statistically, based on corpus linguistics, you can get an answer. That's great. But unfortunately, that's no good for NLU. Because if you discuss the dogs on the beach, you're either on the beach discussing the dogs or the dogs are on the beach that you're discussing. It doesn't matter the statistics because it's the context that resolves it and nothing else. Let's look at parsing at parseface. So this is the world's best achievement at a parser. It's the most accurate parser ever produced. I think it was 2006 Google announced it. And if you look at the announcement, they point out that there's certain types of problems it doesn't handle. And those are based on meaning such as this prepositional phrase attachment. So if Alice drove down the street in her car, is the street in her car, or did she drive in her car down the street? Did she drive down the street? So you understand that there's those two different interpretations. You can see how I've written out with goal versus position and so forth. What's the right answer? There is no right answer. Language allows both. Language is infinitely flexible to allow us to describe what it is we want to describe. If you were forced to use different words because of statistics, then language would be very different. How would the second interpretation work? So the street is in her car. Well, let's imagine Alice is in the back seat of a car with a toy. She's got a little toy car, and she's driving down the street in her car. So the street is in her car because it's the toy, and then she's driving down that street. And cartoons, animations also exploit this. The idea of an elephant flying, for instance, is impossible, but I've seen pink elephants fly in animations. So, what's the alternative? Well, pattern theory with rel and reference grammar. It works perfectly well. It's working based on the meanings of the words. So, when you talk about how you understand a sentence, this is how it works. The meanings of the words in the sentence define the other meanings in the sentence. So the meaning of a word is based on the meanings of the other words in the sentence. There, I've said it better this time. Let's finish with a funny story, perhaps. One of my advisors told Professor Noam Chomsky that my company, Pat Inc., was building a language system that didn't parse or use parts of speech. His answer? Something along the lines of, they sound deluded, like Trump supporters. Our approach clearly is not in the mainstream who followed Chomsky. And thanks for watching today. I believe the current systems have baked in the core hypothesis that meaning should be excluded from our linguistic systems. When I met with global IT giants, it was concerning how limited the knowledge of functional linguistics was, to the point linguists are not commonly involved in their large projects. That's about to change. Next time. The grammatical elements underpinning language are exposed as highly ambiguous and therefore causing phrase duplication and inaccuracy. The meaning-based model is compared. After that, I'll delve into the details of our working semantic model, leveraging the insightful work of another of my historic heroes, the psychologist and cognitive scientist, Professor George Miller, and his WordNet project at Princeton University in New Jersey, in fact, where I grew up. That's all for now. See you soon.